In this tutorial, we're going to look at predicting products for double displacement reactions. Double displacement reactions can be further classified as either a precipitation reaction or an acid-base reaction. So again, when you're looking on Ohm, you will see that typically when you're asked, most all of the questions, if you are asked if it's a double displacement reaction, you'll be asked for that additional classification if it'll be a precipitation or acid base, and we'll review that when we're predicting products. So again, if you've not looked at the section in your textbook and the video on classifying reaction types, make sure you do that first. This will make a lot more sense than if you're just jumping right into this without that background. So we're going to look at 5 different reactions. All of these are double displacement reactions. I can classify them as so because in every instance I have a compound plus a compound. And that's the easiest way to identify a double displacement reaction, is it's always a compound plus a compound. Now, if I look at the first one, my compound HCl plus NaOH, when I'm trying to determine that additional classification, if once it's a double displacement, it's either a precipitation or an acid base. Very simply, if you can first rule out if it is or is not an acid base. The easiest way to do that is look at your 2 compounds. If one of them starts with hydrogen and the other compound ends in OH, then it's an acid base reaction. If that's not the case, then it's a precipitation reaction. So for this first one, I see one of my compounds starts with H, the other compound ends in OH, so this double displacement reaction would be further classified as an acid-base reaction. Okay. You have to see both of those things in order for it to be an acid-base. All right, for double displacement reaction, like you should have learned at this point, this is basically when they swap partners. So whenever you have the positive of one compound combining with the negative of the opposite compound. So when I'm doing double displacement, I typically like to, my first step is to write in all of my charges. Again, this was back from Unit 2. So using your periodic table, hydrogen is a +1, chlorine's a -1, sodium's a +1, hydroxide's a -1. So I always do that as my first step because you'll need those charges for the product side. So this positive charge is going to now swap partners and steal that negative charge. This positive is going to steal that negative. So what that looks like, H is going to come together with OH. If you rewrite that though, that is just water. HOH is the same thing as H2O. So it's a lot more common just to see this. The next one, the Cl and the Na, you always want to write your positive ion first. So that would be the Na and then the Cl. Okay, carrying over my charges, this is a +1, -1, so no subscripts are needed whenever those two come together. So that's it. That's going to be my products. And I think it's already balanced too. Okay, so that's a first example of predicting products for a double displacement reaction. All you're doing is swapping the partners over here and putting the new positive and negatives together on the product side. So number 2, I have lead nitrate and lithium chloride. If I look at those 2 compounds, they don't fit into this, this structure or the skeleton. There's no hydrogen and something else and the other compound ending in OH. I don't see that in number 2, so it cannot be an acid-base reaction. It would be what we call a precipitation reaction. Okay, so again, we're going to solve these the same way that we did above. So I always like to go in first and put my charges. Nitrate is a -1. Lead is treated like a transition metal. It can have a +2 or a +4 charge. In this instance, again, working backwards, we did all this in Unit 2. It has a +2 charge. Over here, lithium is in group 1, so it's always a +1, and chlorine is a -1. So if I swap partners, my lead is going to now take the negative charge of the opposite compound, which is going to be chloride. And then the other positive and negative that are last are going to form the next compound. Remember to always write the positive one first. Okay, now I'm going to go ahead and balance them. So if I look PB and Cl, I'm going to need a 2 here to balance those. The +1 and the -1 cancel out, so there's no subscripts that are needed. Before I continue to balancing the whole equation, I need to determine, kind of like we did for single displacement reactions, if these products are actually going to form. So for the single displacement reaction predicting products, we use the activity series chart. For double displacement reactions, you are always going to use the solubility chart, specifically for those precipitation reactions. A solubility chart, there are solubility rules that is in your textbook. I also uploaded a chart to D2L, which might be easier for you to use also. So I'm going to use the top part. They're the same chart, they're just in different orders. This is another one that you can use to help you. So this chart here, if you've printed it out, you can maybe make a note to yourself that this is used for double displacement reactions and predicting whether or not the reaction occurs. So what we do is very simple. We go to our products that we predicted and we look that product up on the chart. So I have lead and chloride, so I'm going to go ahead and find those two. I found lead 2+ and chloride, and I'm going to see where those meet. And they meet where I have a little gray X. If I look at the key at the bottom, it says that an X is not soluble. I think that Ohm will ask you, I think they'll call it insoluble, but same thing. Okay, if you see an X, it means that it's insoluble. And if it's insoluble, what we put in parentheses next to it is a little s in parentheses. Okay, all right, let's look at the next one, lithium nitrate. All right, I'm going to come to my sheet here, find lithium, find my nitrate, and see where they meet, which is here with the capital S. Capital S is soluble, and anytime something is soluble, I indicate that in my reaction with an AQ. The reason we use AQ is AQ stands for aqueous, which means soluble. A precipitate is whenever a solid forms when you take two aqueous solutions and then you have a solid that forms at the end. That's what a precipitate is. So for double displacement reactions, specifically the precipitation ones, in order to know if they occur, one of your products has to be either a solid, liquid, or gas. The other ones can be aqueous, is fine, but you have to have at least one solid, liquid, or gas for the reaction to occur. Since we do see a solid, then we know, yes, this reaction does occur, and then I can finish it up just by balancing my coefficients, which I think I just need a 2 here and a 2 here. Okay. All right, let's try another one. Number 3, I have H2SO4 and BaOH2. If I look at this, double displacement, because I have compound plus compound, this first compound starts with an H, this compound ends with an OH, so I know that this double displacement reaction can be further classified as an acid-base reaction. So I'm going to go ahead and predict my products. The H and the OH come together, just like it did up here. And I forgot to write our charge, which is a +1, -1. Anytime H and OH come together, you can just go ahead and write that as water. And then your other product, and I should have put in my charges. When the other two that are left, the BA and the SO4 come together, okay, that's going to be a +2 and a -2, so no subscripts are needed. And I do not have to use this solubility chart because this is going to be specifically used for precipitation reactions. Okay, and this one I classified as an acid-base reaction. So I would just have those two products, and then that's it. Okay, so I think in order to balance it, I just need a 2 here. All right, for my fourth example, I have sodium phosphate. I'm going to go ahead and write in my charges, aluminum nitrate. And I want to predict the products. I need to know if a reaction takes place and predict the products. So again, my positive from one, oh, before I do that, I should back up. My additional classification, I know it's not an acid base. It doesn't have a hydrogen and an OH, so this is going to be a precipitation reaction. Okay. The positive Na is going to bond with the negative from the other one, which is the NO3. And then the aluminum and the phosphate are going to come together. Again, remember, always write your positive one first. Okay, so it's super nice when these come together, all of those charges cancel, so I don't need any subscripts. Since it's a precipitation reaction, I have to pull out my chart and determine whether or not a reaction takes place by looking up the products. And that's another note if you want to put on yours. Only use this chart for your products. You don't use it for your reactants. Okay, so my first product is NaNO3. And I'm going to look up Na on here, which is somewhere, sodium here. And then nitrate, which is down here. And if you pull them together, you get that capital S, which we said means soluble. When something is soluble, you write it as AQ, which means aqueous. Next one's aluminum phosphate. So I'm going to find aluminum and phosphate. If I go down, I get my X. X's mean insoluble or a precipitate. So that would be marked with an S for a solid. And if you want to put a note to yourself, if something's soluble, you always mark that as AQ. If it's insoluble, that gets represented in the chemical equation with an S. So that might be nice to have. All right, so since one of my products is a solid, I have to have at least one of them as a solid. I know this reaction does occur. And then my last step would just be balancing it. And I think it's just a 3. Okay, for my last one here, number 5, I have calcium nitrate. I'm going to just go in and fill my charges in, and sodium acetate. And if you look at this, it cannot be an acid base because it doesn't have a hydrogen and an OH on the 2 compounds. So this is another example of a precipitation reaction, which means I have to see a solid in one of my products. So precipitation means I gotta use this at some point. All right, so my positive and negative are gonna come together. I have my calcium with the acetate. Okay. I'm gonna bring my charges over. And then I also have my sodium with my nitrate. Okay, so for this compound, I have a +2 and -1, so I need to put parentheses and multiply that by 2. +1 and -1 cancel each other out. We're good there. So next I have to, since it's a precipitation, I have to look and find the phases of matter of each of those compounds. So first is going to be calcium acetate. So if I look at my compound calcium, you'll see the acetate here is written slightly differently. There's a couple ways that you can write some of these polyatomic ions. If you want to put your note to yourself on here that you might also see that acetate is C2H3O2. If you count them up, you'll see it's the same thing, but sometimes right off the bat, it's nice to maybe just have a note to yourself. So if I take a look at calcium acetate, I see the capital S, which means soluble, and soluble means I'm going to put the little AQ sign next to it. And then next I have a sodium nitrate. So if I look up my sodium in my nitrate over here and see where